Do we get?
Yes.
Do you all have the Z table?
Yeah.
You find at the end of the curriculum. Even it should be in Shredder as well. Okay. Check what -1 is. Okay, the first question I should ask, do you know how to check the...
That's okay. Because it's not easy to check.
Okay.
That thing is not simple to check.
Let me see if I can project the Z table. Okay. So this is the Z table. So I was saying, if you are asked to, if you are given an example like the one I just created there, where this is a standard normal distribution. Okay, maybe I should start. For you to use this table, you must standardize your normal distribution. And there's a formula for standardization. You understand? Which is the formula that we use to determine what our Z would be. So if I gave you a question, because I've already standardized this -1 that I have here is like my Z figure. Why? Because we said f of -1 is the same thing as probability of x less than or equal to -1. And our Z table is defined as p z less than or equal to x. In this particular instance, my x is -1, right? So my z is -1. How do you now check the table? Here you have x or z. Is it clear? What you have here is x or z. So here you have 0, -0.1, minus whatever. In this our example, it is -1. So you look for -1 here. This is -1, right? If it is -1.2, this is -1. Here you have 0, 0.01, 0.02. So you trace this line to this 0.02. So this number that you have here would be the probability that is represented by this shaded area. Is it clear?
What you're saying is -1.
The probability is not the minus. The z is the minus. Is the one that has -1 point whatever. Inside this table, what you have inside this table is the probability.
When you said 1.2, it's like 1.0.
Okay, sorry. It was 1.02 that I wanted to. Sorry. 1.02. You can even see if this is -1 and this is just the second figure, that's 0.12. If it's -1.2, it should be this under 0. Do you get? So it's easy to check. Now it's possible that if I ask you that what's the probability, no, don't worry, don't let me complicate things yet. But we know how to check. We know how to check our z value, right? Okay.
I understand how to use it. I don't know why I'm using it.
You don't know why you're using it?
Yes.
Good. Why you are using it is you are trying to calculate probability. You understand? The probability that is defined by this z distribution is the probability of x less than or equal to a particular z value. They can be related. Let me explain how they are related. I can check the z value for 95%. Remember I said inside this table is where you have the probabilities, right? And for a normal distribution, we know the difference between one tail and two tail, right? This is a two-tailed distribution table. So if I say find 5%, 95% confidence level. If I say find 95% confidence level, remember we said the confidence level is how many standard deviation away from the mean, right? So if it's 95%, if this portion that I put this dot dot is 95%, and this distribution is symmetrical, so what would this tail be? 2.5, because it will be half of what is left. Do you get? If we say this distribution is symmetrical, that means this half is equal to this half, right? And we said for confidence interval, what we're trying to calculate is what is the probability that our outcome will be between x, maybe x, z standard deviations from the mean. Let me use z standard deviation from the mean. I said if we are looking at two standard deviations from the mean, for example, our z will be 2, right? So two standard deviation would look on this table for 2.0. This one is minus, right? We also have the positive table. Let me see if it's in.
How do you know that my question is, you're saying that this is a two-tailed.
Yeah.
How do you know this is two-tailed? Because we are sometimes like.
How do we know that it's two-tailed? Now, you get the gist on the confidence interval, Abby. So if I said, what's the 90%? What's our 90% confidence interval? What I'm simply saying is, what is the range of values within which we'll be 90% sure that a variable would be? Am I speaking? So if this is our mean, our standardized mean of 0, and then we're trying to say, what is the range within which you can be 90% sure?
I did not get my question. I understand that it's 25%.
How is it two-tailed, Abby?
So
That's the question.
That table, not that, the table.
Yeah.
You know that this table is two tables, not one table. Because they didn't write it.
A normal distribution, because it's symmetrical, and because the way the table is defined is, if you say calculate z of -1, what you are simply saying is from -1, what's the probability that x will be -1 or less? Do you understand? Which is represented by this portion. Clear? Now we also know that this distribution is symmetrical, right? Because it's normal distribution. So this shaded portion would be the same as this other part. Do you understand? And we know that our confidence level is, we are looking at what's the probability that an outcome will be between this guy and this guy. Do you get? So this is 90%. Our z that we are checking should it be 10% or 5%? It should be 5%, because we know that it's symmetrical. 5%, half of what we are trying to check will be here, and the other half will be on the other side. What was the question?
My question is not about that. I understand that it is the table. This table that is here. Can you pull up this?
How do you know it's two-tailed?
Yes, because there are some of them that come as one, there are some of them that come as two. How do you know that this table is two-tailed? Can you write it here?
For a normal distribution problem, it has to be two tails. If it is T distribution, now you now have to define, am I solving a two-tailed problem or a one-tailed problem? Do you get? Okay, back to how we can use this table to find our z value.
This table is equal to the provided answer.
If they are going to ask you a question that would require the table, they may provide it to you or they will give you the z value.
But I think most times they
But if they're asking for 90%, 95%, and 99%, they will not give you because they expect you to cram it. Do you understand?
Yeah, because this question I saw
90, 95, 99, you must cram it. Yes, you must cram the z value. Will be 0.05. Yeah. 0.5%. 0.005 rather. What is inside there is the probability. Do you understand? So if I say what's 90% probability, like your confidence interval is 90%, to check this table, you would look for where you have 0.90. But if you do for 0.90, you will be wrong because it's a two-tail distribution. Two-tail meaning that it will be 0.95 that I'm looking for in this table. Maybe I should not confuse you then.
Wait, let's just get to the part.
When you started, you said you would do 100 minus 90.
That's 10 now.
That's 10. They divide
Yeah.
by 2. That's 5. So
Yeah.
now again, you're saying it's the 90 I will look for. Which one am I looking
So 5%, that's 5% that you look for, right? 0.05, right? But to look for the probability here, you can look for 0.05 in this one because our z values are negative here. If it is the positive one, you would have the range from 0.5 to 0.9.
Okay, the way I said that we look for 0.9.
In this particular one,
What am I looking for in the table? Is it 0.05 or the 90%?
this is our probability, right? So you look for, remember inside this table, what you have here is the probability. What you have outside is the z value. So if you are trying to see how many standard deviations from the mean is represented by this my z value, like if you're trying to find, in our example I did one standard deviation from the mean. If I was trying to look for what's the percentage or the probability that our outcome will be one standard deviation from the mean, I would have just looked for, okay, 1, that's, where is 1 here? This is 1. We have this table is a minus table. So I'll look for minus 1, which is this. Do you understand? And I'll now subtract this from 1. So that will be 0.8413.
Why are we subtracting from 1?
Because the table is a negative. If the table was positive, you would have just picked the figure. I'm sure if you have the positive table, it will be 0.8413. You have the positive table, have you? I think I've confused you people. So let me restart. Let me restart.
Sorry, I have a question.
Ask.
Like, very, very far. Like, have you gone very, very far?
In this, no, we've not gone very far. Okay. So let me go back to where we're coming from, so that I'll put the pieces together.
Would you make more time for us to solve questions?
Yes. Okay. Maybe I should even go straight to this table. Now, in this table, what we have here for one standard deviation from the mean, we said is 68%, right? Now, when we check that table, what was our z value? Okay, this one is negative. Do you have the positive one? So for one standard deviation from the mean, we're trying to see what would our z value be, right? So one standard deviation, that's 0. I'm coming minus 1.68%. So 68%, 1 minus 68% is what? 1 minus 0.68.